In this video, I'll show you how to solve the ALEKS problem called predicting how reaction rate varies with pressure, concentration, and temperature. This problem is going to give you a balanced chemical equation. You can go ahead and ignore it. It's also going to give you some numerical data. You can ignore that as well. That's just there to distract you. You don't need any of that information at all to solve this problem. Let's go straight to the actual data. So in this problem, you have 4 different reaction containers, A, B, C, D. You've got some information about the volume and temperature of each one of those containers, and you're being asked to rank them in order of their rate of reaction, fastest to slowest. Now, some versions of the problem are going to look like this one, where all of your reaction containers have the exact same volume, so you've got constant volume, but your containers vary in terms of their temperature. There are other versions of the problem where your temperature is constant, but your volume is varying. And then there's a third version of the problem where you have a couple different temps and also a couple different volumes. But don't worry, I am going to show you how to solve all 3 of those different types. So for this version of the problem where you have constant volume, we're looking at the temperature. We're comparing the temperatures, and the higher the temperature is, the faster the rate of reaction. This is because as the temperature is high, the molecules are moving super fast, they're reacting more quickly. So if you have this version of the problem where volume is constant, we're just going to be ranking these reactions, the rate of these reactions by their temperature. And ALEKS is using, I'm double checking, yeah, ALEKS is using a number 1 for the fastest or the highest rate of reaction. And then we're just going to go from there, going down temperature. Our lowest temperature, that one is going to be slowest. Okay, that's not so bad. Now, if you have a different version of the problem, let's say you have a version of the problem where your temperature is constant, but your volume is changing. So I'm going to erase this ranking, and then let's just make some changes here. Let's just make all of these 9 degrees, so they're all at the exact same temperature. And then let's just change the volume. We'll make that one 15. We'll make this one 2. We'll make this one 9. Okay, so if we have constant temp, but different volume, the smaller the volume is, the easier it is for the molecules to bump into each other because they're jammed into this little teeny tiny container. And the low volume is going to be the one that has the fastest or the highest rate of reaction. So looking at, and again, this is only if your temperature is constant the whole way down. So looking at these, our smallest volume, that is the one that is going to have the highest rate of reaction. And then we're just going to go up as our as our volume gets larger, our rate will slow down. That's not too bad. Now there's a third version of the problem where ALEKS will give you a couple different temperatures and a couple different volumes. This is the trickiest of all of the different versions of this problem. So I'm going to modify this a little bit. I'm actually going to erase this as well. And then we're just going to come up with some new temperatures. Now the versions that I'm seeing of this problem, ALEKS is not going super crazy with the temperatures. I'm just seeing 2 different types of temperatures, 9 and 10. And then I am also going to change some of these volumes as well. So we'll go like that. And in this case, since we've got variation in the volume and the temperature, the first thing that I want you to do is rank them by temperature. So we're going to, I'm going to change that a little bit, pick the highest temperature first, and of the highest temperature, the one with the lowest volume. So we're looking for, of the containers that have the highest temperature, the one that has the highest temperature and the lowest volume. That's hitting this and this as well. That is going to be our fastest or our highest initial rate. Kind of on the flip side, the one that has the lowest temperature, which is 9, the lowest temperature and the largest volume, that one is going to be our lowest or our slowest rate of reaction. Of these 2 that I have left, they have the same volume, but one is higher temperature than the other. So our highest temperature, our higher of the 2 will be number 2, and then The lower temperature will be number 3. This, if you have, or I guess you'll probably end up with this, when you have a version of the problem like this, it is a little bit trickier to solve. I think the easiest way to do it is to find the absolute highest, meaning highest temp, lowest volume, and then also find the absolute lowest, meaning lowest temp, biggest volume. And then you should be able to rank the other two because they should have one number in common like that. Good luck with this problem.